Now that we made the connection of the ultrasonic sensor to the robot, I'll repeat the pin connections again. We've connected trigger. I'm going to write it down here so it's easy. I said we used trigger connected to pin number 8, and then we had echo connected to pin number 9, and then we had I1, I2, I3 and I4 connected to 4, 5, 6, 7, but I'm not going to use that now. This program is specifically for the ultrasonic sensor. So I'm going to save this code and say ultrasonic sensor, okay, and I'm just going to save this in my folder. So yes, okay, the code is saved. Now I have to declare this as integer trigger equal to 8 semicolon, integer echo is equal to 9 semicolon, and then I go to my void setup. I'll declare both of these pin as input and output. I'll say pin mode trigger is output because I'm supposed to trigger, and then pin mode echo is input because I'm supposed to be measuring. I'm done with this and I'll go ahead and write the code. So first thing I do is to trigger. How do I trigger? I make the trigger pin low for a while. I'll say digital write trigger low. I make the trigger pin low, and then I immediately make it digital write trigger as high. Now I press the trigger, it's on, and I have to immediately make it low with a very small delay, and this delay is supposed to be in microseconds and not milliseconds, for which I'll use a special function called delay microseconds. It is delay microseconds, and I'm gonna turn it on and off for just about 10 microseconds. So I make this low. Alright, so once this is done, I'm done with the trigger part. Now it's time for me to do the echo part. So here I have a special function called pulse in. What does this do? This measures the duration of the pulse, for which actually is giving me the time duration for the ultrasonic wave to go hit the obstacle and come back. So it's a two-way distance. The ultrasonic wave hits the obstacle. Ultrasonic wave from here, from the transmitter, goes all the way, hits the obstacle, and then comes back to the receiver. Now the pulse in is actually giving me the duration or the time of flight, or whatever time it takes for this to go hit and come back. Okay, and this is usually going to be in microseconds, and this is how we read it. We'll say int duration equal to pulse in, I is capital, pulse in which pin? Echo pin. What are you checking for? When the echo pin is high. Okay, I'm now measuring the pulse width of this particular pulse. This is going to give me the duration of the flight. Now I got the duration, but can I check for duration one way? So I'll say int duration okay, I'm gonna make this time taken, okay, and then gonna bring it to duration. So time taken is the whole thing, but my duration is gonna be time taken divided by 2. So I am getting one-way distance now, not two-way, but only one-way time is what I am measuring. So let me check if I can actually read what's coming using my serial monitor, and let me upload the code. But I think I have forgotten to add the serial dot. Oh, okay. I'm supposed to put this here, and then here I have to use the serial dot print line duration. So this duration is going to be give me the one-way time. And let's give some delay. $200 milliseconds and upload. And now that I have uploaded the value here, I am getting about 2250, 2255. Now this is the time taken for the wave to go hit the obstacle once. Now what I do here, when I bring the obstacle closer to the robot, you'll see that this duration reduces. And as in when I move far away from the robot, I see that the duration increases. But what happens when I just bring the obstacle all the way close to the robot like this? The robot usually doesn't see anything, so the values again go up to 2100 change, which means when the sensor is out of range or it is not able to measure, you will get a reading that's beyond 2000. So you know for a fact that if that is a value that you're getting, which means it's out of range, because this sensor can only measure anywhere between 1 or 2 centimeters all the way up to 1.5 meters or maximum 2 meters and not more than that. Okay, that's what we'll use a sensor for. So this is what is our duration. I'm going to close this. Let's now use a speed formula to calculate the distance, and that will give us the distance from the sensor to the obstacle. Now that we've got the duration, let's calculate the distance. We know speed is equal to distance by time. Okay. Now I'm going to put this in comment line so that it doesn't affect my program. Okay. So I'll say speed is distance by time, and then I know distance is equal to speed multiplied by time. Now I know for a fact that distance is equal to speed of sound, which is about 343 meter per second, and that multiplied by time, which is actually the duration. But I have to convert this duration, which is in microseconds, to seconds. So how do I do it? I divide this by 1 followed by 6 zeros. So this is going to convert whatever duration is in microseconds to in seconds. Okay. Now I'm going to bring this formula up here. Control C. And then I'm going to say, now distance is not declared as a variable. I'm going to declare it as a variable, but I know that this is going to be in centimeters and it will definitely have decimal points. So I'm going to declare a variable which says float. Float is decimal declaration. When I have to use integers, it is minus infinity to plus infinity with 0, 1, 2, 3, 4, 5 with integral values. But when I use float, I'm going to get decimal values. Suppose something is like 10.91. I'm going to get that value only when I use the declaration, the variable as a float. So another thing that you have to keep in mind when you do this is that you have to make each of these values with 2 decimals, just adding zeros after a point. And then this duration we know is actually this. And then if I have to get something in meters, then I have to convert this to 00. Okay. Now this will become centimeters. If I have to convert this to, let me just copy this. Yeah, so it will become centimeters per second and duration in seconds, right? Okay, cool. We've got this. We're good to upload the code and also check for distance. So for that, I'm going to use a serial print, and instead of duration, this is going to be distance, and this I'm going to make a comment line, upload the code, expected a semicolon, upload the code, upload it, and then check for distance. Right now it says about 77.31. Let me place a scale and check for obstacle. Says 3 point something and then goes all the way 10, 11, 9, 13. Okay. So this is how I measure distance, and this distance that I'm getting is in centimeters. All right. Good. Fine. So we can use the same sensor and the same program to actually program a robot in a way where I say if the obstacle is at about 5 centimeters, then turn right. And if there is no obstacle, which means the value is greater than 5, then keep going straight until unless the obstacle comes closer to about 5 or 6, and then I say turn right or turn left. The robot doesn't have sensors on both the sides, it has only one sensor, so it can only detect things in the front. You can use the same robot with 3 sensors, one on the right, one on the left, and make this robot go around everywhere. But with one sensor, it will still go find an obstacle and then take a right or left and then keep going. This is what we're going to do next with measuring with the ultrasonic sensor and the robot. Now we have understood how ultrasonic sensors can be used to measure distance, and this is the program we use to measure distance using an ultrasonic sensor. And I'm going to use the same code to control my motor, which means I'm going to copy the same code and create another code and write the program to control the motors. Okay, I'm going to copy this code and use it for the robot. Control Command C, I'll say File, New Program, and here I'm going to use this. I'm going to save this first as ultrasonic sensor robot obstacle avoidance. Too big a name, not necessary. Save. I've saved it. Great. And now I'm going to delete this part of the code and going to paste that code which I used previously. And similarly what I have to do is now do the declaration for I1. I1 is equal to 4, int I2 is equal to 5, int I3 is equal to 6, and int I4 is equal to 7. Now all the 4 pins required for my motor driver are declared. I'm going to use this here and bring in and say, now this is supposed to be pin mode, I1 is output. Okay, I'm going to do the same thing with the other 4 pins, I2, I3 and I4. Okay, cool. Now this part of the code is actually distance measurement. This part of the code is distance measurement. I don't need this duration. Okay, and I can print the distance and all that. So this part is the distance measurement, and then next part is the motor control. Now what I'm going to do is I'm going to now measure distance and then take a decision. I'll say if distance is less than 10 or 5. If distance is less than 5, then what do I want my robot to do? I want my robot to go right. Okay, I want to keep turning right. I don't give a delay here, because if I give a delay, the robot will turn right indefinitely. I mean, even when the sensor is not detected. So what I'll do is I'll ask the robot to go right, and then I'll say else. And there are only 2 conditions: either the obstacle is nearer or it's far away. Okay, I'll say else. What I want the robot to do is keep going forward. It's a robot to go forward. Now we know for my robot to turn right, I have a code which we had written long back. It says digital right I1 comma I1 comma high. So I'm going to copy this. Okay, your left motor is supposed to go forward and the right motor is supposed to go reverse. Left motor is supposed to go forward, so it is low, high, and the right motor is supposed to go reverse. Okay. So what happens here is if the distance is less than 5, then the robot will start turning right, else the robot has to keep going forward. This is the easier way of typing the code. But ensure that you change the values. If you don't change values, robot will go hayway and you will not know why it's happening that way. Okay, so this is for the robot go straight, and then if the distance is less than 5, take right, and if else, keep going straight. Let's go ahead and upload this code. And I think I better give the thing here where I'll be able to read what's happening. Serial.println robot in double inverted commas, robot turning right, and then here I'll say this is robot going straight. Okay, I'll upload this code, done uploading, and what's happening is something that I do not know because I'm not turned on the battery. Let me go ahead and turn on the battery. Why am I not giving a delay in the serial monitor here is because if I give a delay, my robot will spend time in displaying and not actually take action. Okay, I can give a little delay here, just about after everything. I can give a small delay, say about 200 milliseconds every loop, and then upload and check. The robot is going straight and it's about 77 centimeters. The moment you see till it's about 6, 5, and the moment it reduces below 5, you'll see that the robot it's going straight now, and now it's actually taking a right turn by this going forward and this going reverse. Yeah. Now the robot is turning right, and when actually the robot turns right, the obstacle is no more present, and now the robot goes straight. And the moment it detects an obstacle, it will turn a right and will come back. What happens when it detects an obstacle? It always turns right. Now you could change the program to do multiple things. Let me turn on the robot. You could do multiple versions of this code by telling, okay, if I detect an obstacle at 5 centimeters, I want the robot to slow down first, come back a little, and then slowly take a right turn, check if there is an obstacle, and then come back and check left if there's an obstacle, and then take a decision whether to go right or left. This is something that you can do. All you have to do is use if else, if else, if else statements, and then take decisions. But I'm not going to spoon feed this to any of you. So I'm going to ask you to do this, where I want you to do multiple iterations of this code, where if it's about distance is 2, when you see an obstacle present at about 20 centimeters, I want you to slow down the robot. And then when it reaches the obstacle, I want you to then take a right turn or left turn and then keep going. I want you to do this and try this out, and this brings us to the beginning of autonomous robots, where you're able to ask the robot to perform certain tasks with the help of sensors on board. No command, you're not asking it to do anything, you're just letting it on the ground and the robot is running around. And interestingly, this is the very first time you've used sense, think, and act as part of the robot building process. Now, we understood that robots have sensors, they're supposed to think, they're supposed to act, but even when we did the line follow robot, we never used the thinking process because the robot was hardwired. If there's an obstacle, if the sensor detects white, go forward. If the sensor detects black, stop. That was hard coded. There was no thought process thinking about it. So these are called beam bots, and we'll cover it in a later aspect. But this is the very first time you've used the concept of sense, think, and act, and this is something that we've been able to build because of understanding how sensors work, how we actually program, and how we actually get to control our